Okay, I just wanted to go through a little recording for you guys and talk about some of the items on my portion of the test that were problematic. First one is that I want to talk about is question 2 on the flow volume loop, and some of the stuff that people got wrong is they weren't putting in volume in the proper axis, or they had time in on the axis, or had flows flipped around. The other thing is this requires you to do a little bit of reasoning because you have a peak expiratory flow rate to peak inspiratory flow rate of 0.33. So if you think about that mathematically, the inspiratory flow rate must be 3 times higher than the expiratory flow. To turn that around, if you look at it as a fraction, the peak flow is 1/3 of the peak expiratory flow is 1/3 of the peak inspiratory flow. And you have to be able to do this. This is just problem solving and applying the math skills that you've got. So you've got to be able to put the axes together. We've got volume on the x-axis, and I wanted you to try to scale it. So I've got my 1, 2, 3, and 4 liter volume measurements. And then expiratory flow, obviously, we've got on top, like we always have. Inspiratory flow is on the bottom. So if you were to draw your graph should look, and this is what I did obviously on PowerPoint, should look something like that. So we've got a peak expiratory flow of 1, peak inspiratory flow of 3. Calculate out that ratio. Sure enough, the peak expiratory flow is 1/3 of the inspiratory flow. Now this was part of a case. And the second part of the questions for that case are to be able to identify what's going on with that flow volume loop. And a lot of you had in your cards the pictures of these flow volume loops, and if you put those on your cards and matched them up correctly, you'd find that it was a variable intrathoracic obstruction. This is the film from that same patient with that same flow volume loop. So the concept for a variable intrathoracic obstruction is that during expiration, forced expiration, when the airway, the pressure outside the airways is greater than the pressure inside, it's going to collapse the airways. So we go to this patient's chest film. This patient does have a tracheostomy tube in place. That was one of the questions. This patient does have something else that's abnormal in the airway, and that thing is a stent. The stent is there to keep those large airways from collapsing. So this patient had tracheomalacia. The cartilage rings have been softened. When he forced exhales, actively blows, he's going to close that major airway down. So you're going to generate collapse. The other thing that's on this film that's abnormal, and I'll just get rid of that again, is that there's a patch of atelectasis that's down in that right base. So that's the other issue that you're looking at. This is that plate-like or discoid atelectasis, subsegmental atelectasis. It's not the whole segment. It's certainly not a whole lobe, but that's what we've got. Those 3 things that are major findings on this film. Tracheostomy, tracheal stent, which actually goes into both right and left mainstem. You'll see that it branches or bifurcates, and then you see that little patch of subsegmental atelectasis. This next patient had a significant problem that was underlined in the quiz, a lung problem, and that lung problem is this. That's not hemidiaphragm. Well, part of it is an elevated hemidiaphragm, but that's right lower lobe atelectasis. You know it's in the right lower lobe because you still have a fairly clear right cardiac border. You can see that right heart border. So this tells you that this abnormality is a right lower lobe abnormality. Next, we've got this patient's film. Obviously, this patient is intubated, and if you look carefully, they're intubated in the right mainstem. This is a major thing that everybody needs to be able to pick up. And obviously, if that is a right mainstem intubation, it needs to be pulled back. For one thing, if you don't pull it back, you're going to get left lung atelectasis because the left lung is not being ventilated. All of the volume is going into the right lung, and there's a potential for us to generate a pneumothorax from that if we overdistend alveoli. So the response there is that you definitely have to pull that back. The last one of my items that people seem to miss points on was number 6. It was the DLCO question. And it really asks, what's the purpose of the tracer gas when you're doing a DL maneuver? Remember, the key words in here is we're doing DLCO. So that's the test. It's not a helium dilution FRC measurement. We're going to have the patient exhale to residual volume. Then they're going to take the deep breath of that gas mixture, and that gas is going to be diluted by the residual volume. They're going to take a vital capacity breath in. They're going to go to total lung capacity, but the tracer gas is going to be diluted. And the carbon monoxide is also going to be diluted. And that's what's important, because remember, we're looking at how many milliliters per minute per millimeter of mercury are diffusing. Well, we've got to know what the pressure is in the alveolus of carbon monoxide to determine what that pressure gradient is for diffusion. So the second half of that answer should be that we need to know how much the carbon monoxide is diluted in order to calculate the partial pressure of alveolar carbon monoxide to be able to calculate the gradient. So that was the last question that people seem to have the most problems with on my portion of the test. So I hope you find this helpful. If you still have questions on it, please don't hesitate to come and see me.